video is going to review solving radical equations. And what we learned in class today is when we have radical equations, we have to think about restricting the domain before we even start. So for this particular problem, I'm going to set the radicand, or the underneath part of the radical, greater than or equal to 0. And when I solve that little inequality, I get x is greater than or equal to -2. Normally, we've got to do the same thing with whatever your output is going to be over here. In this case, the output and the radicand are the same, so I can skip the second domain restriction. Otherwise, they'd be exactly the same. The next thing that I'm going to do is undo the square root, and I undo the square root by squaring it. That's going to give me x plus 2 on the left. And if I use the jingle instead of the box, I'm going to square the left, which gives me x squared. I'm going to square the right, which gives me 4. And I'm going to double the product. The product is 2 times x. If I double it, I get 4x. If you do the box to multiply x plus 2 times x plus 2, you're going to get exactly the same thing. And then next, I'm going to move everything to one side so that I set my equation equal to 0. That gives me x squared plus 3x plus 2 on this side. And I'm going to attempt the x box, remember, for about 20 seconds to see if this is factorable. So I'm looking for numbers that multiply to give me 2 and then add up to give me 3. Turns out 2 and 1 are those magic numbers. If I factor this, I'm going to set up my factor box. The GCF of the top row is x. The GCF of the bottom row is 1, which makes across the top be 2. So I'm looking at x plus 2 equals 0 and x plus 1 equals 0. That's going to give me two solutions, x equals -2 and x equals -1. But then remember, I'm going to have to take each of these and I'm going to have to check them with the domain restriction up here to see if they're really solutions or if they're extraneous. So if I check x equals -2, -2 fits the inequality, -2 equals -2, so that one is a solution. And if I check -1, -1 is greater than or equal to -2, that also fits. So these are both solutions, neither one of them is extraneous. This problem is just a little bit different because we have a radical on both sides. So in this case, I'm going to still have two domain restrictions, but they're both going to come from each of these individual radicands. So I'm going to have 3x plus 1 is greater than or equal to 0. And when I solve that, I'm going to get -1/3. X is greater than or equal to -1/3. And the second one, I'm going to have x minus 5 is greater than or equal to 0. And if I solve this, I get x is greater than or equal to 5. The next step is, of course, going to be to square both sides. And this kind of problem is particularly nice because now I just have a linear piece on each side, and it's going to be much easier to solve. So first I'm going to move the x's onto the same side. So I'm going to subtract x from both sides, and I get 2x plus 1 equals -5. Then I'm going to subtract 1 from both sides. That gives me 2x equals -6. And when I divide by 2, I'm going to get x equals -3. The only other thing left to do is to go back up and check to see if this fits the domain restriction. So we're going to ask ourselves, is -3 greater than or equal to -1/3? -3 is not greater than or equal to 1/3. It does not fit that domain restriction. And -3 is not greater than or equal to 5 either. So it doesn't fit either of the domain restrictions. So it is not really a solution. So in this case, this particular equation has no solution. This is the symbol for the empty set. That means no solution. Or you can write out the word no solution. If I think about what this would look like on a graph, I would have two square root functions on my graph, and they would never intersect. This is going to be the last solving radical equations problem I'm going to demonstrate in this video. This one's a cube root function, and cube root functions or cube root equations are different because it's okay. The domain for a cube root function is all real numbers. It's okay to have a negative number as your radicand. It's okay to have the negative underneath the radical. So there are no domain restrictions that go with any kind of radical equation that has an index. Remember, this is the index, an index that is an odd number. So I can just go ahead and solve this. The first thing I'm going to do is notice that I know what the cube root of 8 is. That's a regular plain old 2. So I'm going to simplify that part. I still have the cube root of 2x plus 1 on this side. I want to undo the cube root. So I undo the cube root by cubing both sides. That's going to give me 2x plus 1 equals 8. When I subtract 1, we get 2x equals 7. And then if I divide by 2, we get x equals 7 over 2 as our solution.